Okay. Hello. Just give me 1 second. Okay. So hello everybody. Thank you for joining us. We are here for this this third appointment this year with our webinar series, which is part of our AM focus calendar. And just to just summarize really quickly what that means is every 2 weeks this year, so 20 different topics a year. 3D Printing Media Network, our main editorial website, is covering a different topic, a different vertical in this very highly horizontal industry, which is 3D printing. We began with composites because, of course, our verticals can be applications or materials. So we begin composites. We discussed orthopedic implants, and today we're here to discuss the first real consumer applications that could the first consumer application that could really start to be mass produced or at least mass customized through 3D printing, because of course you could consider medical and dental also consumer applications, because ultimately they go to consumers, but we're talking about mass products, and we consider in this category we consider products like eyewear, like shoes, and these are products that incidentally the main difference is that they're not as expensive. The final product is not as expensive, so it's much more challenging, I think, to integrate 3D printing into the production process of products that are produced in such high numbers, but the final product is not so expensive and it goes to a consumer, so the consumer is much more limited in his purchasing power than, for example, an aerospace company, or somebody who's paying for something that is necessary for their health or for their life. Of course, eyewear is borderline. We did discuss this. It has very significant health applications. So this is why we think this is going to be the first consumer product to really make it that can really start to benefit from 3D printing as a mass production, as a mass customization technology. So without further ado, we have here, I think, some of the pioneers and the leaders of the eyewear 3D printing market, because we can certainly say that Materialize is the company that's leading this market, because it's the company that's producing the most eyewear frames. We have Biki, who's Hoe from Hoe Studio, who is, as far as I know, if not the first, one of the very first studios to really start producing eyewear frames with 3D printing, both in polymers and in metal. And we have Guido Groet from Lux Excel, which is the first, and as far as I know, even though there are companies that are starting to look at the market, the only company that can produce lenses for glasses. So these are all components of what we consider eyewear. And just to kind of set the context and set the stage, I'm going to give a little presentation from our latest report on the eyewear AM market, which was published by Smart Tech Analysis. By the way, for those who don't know me, I am David Descher. I'm the founder of 3D BPM, which is the company that publishes 3D Printing Media Network, and I also work as a senior analyst for Smart Tech Publishing. So we basically cover the industry, both day to day and as far as underlying macro trends that are taking place. So let me just very quickly share my screen and find my presentation. I've done this a few times, but I still have a hard time with the controls. So here we go. Let me just go to the beginning. You never really fully learn how these webinars go, but so By the way, you're all participants are able to ask questions. Feel free to write them in. We are going to give now short presentations of the applications in the from the panelists companies. And so after these presentations, then we'll begin a discussion, and we're happy to take questions from the audience, and also try to highlight the main issues that have come up. So without further ado, let me begin uh, to just try to kind of contextualize this market. So we've seen this market really grow over the past 5 years. Like 5 years ago, 5 or 6 years ago, people started thinking about the idea of really using 3D printing to make custom eyewear or to make particular innovative designs using 3D printing. And 5 years ago, it was really just ideas, and now we're really starting to see production being taking place. So this is, there already is some significant production taking place in the eyewear business with 3D printing. And 3D printing is opening up opportunities for businesses of the eyewear market is a market dominated by some large players, but 3D printing is opening up possibilities for new players, for smaller companies to produce on demand, to produce to really produce without necessarily having to rely on scale economy. But at the same time, the challenge here is scaling up with 3D printing, so fully scaling up the business. So what do we mean by eyewear? In this report, we're covering glasses, which are made of frames and lenses, of ophthalmic lenses, sunglasses, and other products such as mostly future products that will come in a few years, such as AR and VR visors, and we expect an increasing use of eyewear in even connected and smart eyewear in sports and in professional activities. This is we expect we see the eyewear market we expect it to be worth about the overall market is probably worth about 100 and some billion today. I'm sorry, 123 billion today, according to the various data that we collected. And we expect that it's growing fast. It's growing very fast, and it's going to grow faster because of new products that are going to come out. And we expect it will be worth 230 billion by 2028. And we expect 3D printed eyewear to be worth about 1.9 billion out of those 234 billion. So this is only 3D printed eyewear final applications. So how does does this business model work? This is where 3D printing, eyewear 3D printing is maybe a little more similar to dental 3D printing, because it all starts, and not exactly dental 3D printing, but for some parts of it, it all starts from the optician's studio. So like you would go to the dentist, you would go to the optician, to get lenses, to get frames custom made for you through 3D scanners. The alternative in eyewear is that you can also do this via app, but obviously the customization would be lower, but the scalability would be higher. You define your personal needs, and by the way, we also elaborated this from a materialize chart. That we picked up and we kind of worked on and customized. Then you would select your lenses, you would select your designs, and then you would order it, and it would be produced on demand and delivered, custom eyewear delivered to you within 10 weeks to 10 days to 2 weeks. So where does this leave us? This is what we think the industry will, the eyewear 3D printing industry will look like. It will be mostly it already, so in eyewear, final applications already represent the largest value, the largest business, which is a unique, according to our projections, according to our estimates, it's unique. There is no other consumer segment where applications are already, where production already is the biggest segment. But we think it will be by far the biggest segment by the end of the forecast period at 1.9 billion. Other relevant segments, of course, will be prototypes made with 3D printing, fast tooling, fast cast patterns, fast pattern production with 3D printing, and of course, 3D printing hardware and materials. Of course, because 3D printers have some significant productivity. You don't need that many 3D printers to make a lot of glasses already as it is. So 3D printing hardware may not be as large a segment as it is in other segments that we cover, like, for example, aerospace. So I'm gonna kind of skip over this. So which are the drivers for using 3D printing? One is the increased design possibility, especially through powder bed fusion technologies. Customized comfort through so designs that are more comfortable, lighter, more that feel nicer. The material quality, because although material is for some reasons it's in some markets is considered a limit, in some other markets, the nylon, the quality of the powder bed fused, the nylon used in powder bed fusion is actually quite is actually a very resistant material. And if companies have developed, startups have developed methods to do post processing so that the quality is actually better than traditionally manufactured eyewear. But that's not always the case. Another advantage is the ability to do on-demand manufacturing, so reducing the impact of scale economies, and of course, the fact that in such a fashionable segment, which changes so fast, you don't have to build up stocks. Increase innovation, and of course, by new studios and smaller companies. Challenges is the fact that the surface is rougher, so you need to companies you need to do some finishing, which kind of limits the surface of the eyewear produced with powder bed fusion is generally rougher, so you do need to do some post processing, which generally limits the benefits of scalability of on-demand production. Limitation is which that's my second point. It's hard to scale up with 3D printing. It's hard to scale up production, to fully scale up to meet the demands of a large market such as the eyewear market. Limited material selection still, and the fact that finishing processes are labor intensive. Which are the main technologies that we've seen? So production is almost entirely done by powder bed fusion. Material jetting is used for high-level prototyping by large companies, and it's going to be used more and more. We think, and we've seen that both photopolymerization and filament extrusion are used for some basic, low-cost and desktop prototyping, and bad photopolymerization technologies can also be used for pattern production and casts and everything that's in indirect production, what we define as indirect production through 3D printing. Also, we should say, the materials are of course nylon for powder bed fusion and some photopolymers. Photopolymers for material jetting and bad photopolymerization. But we should also say that, of course, there are technologies that are using, for example, LuxExcel will explain later, the particular types of materials, of acrylic materials that they use for production, and also metals are used, although in a very limited fashion today. But there have been workflows identified where it's beneficial to 3D print hinges with metal, or as Jorge will discuss later, entire frames in metal. So this is the as far as hardware, we're looking at a market. So as far as AM companies are concerned, we're looking at a $166 million market by 2028, and this will be mostly represented by photopolymerization, powder bed fusion technologies, which include both the laser sintering, but also we think increasingly so the HP's powder bed fusion, and with the photopolymerization second, because we think indirect production is going to be significant, and also because we think that photopolymerization processes are going to be used for some end-use production, the carbon-like technology, so fast production with photopolymers. There are no examples today from what we've heard from market players. The materials are not are not qualitative enough to do end-use eyewear yet. These are some of the machines. And by the way, this will be available upon request to all participants. So I'm just going to go through them really quickly. And this is the one of the, I think, one of the intermediate steps that's going to be necessary for eyewear to really take off. Eyewear 3D printing to really take off is the ability to acquire the 3D data. And we think this is going to happen really fast. It's going to happen really fast through 3D scanners, custom eyewear 3D scanning systems in optician stores, and also through mobile app, mobile app that leverage the 3D scanning capabilities of latest generation mobile devices such as iPhones and so on. So without further ado, I would like to pass the controls over to the panelists so we can see what the real applications are today of 3D printing in eyewear. I haven't set I haven't really set how do you say an order, so I will go in alphabetical order. So we will start with Ali Reza from Parandian from Materialize. And Ali Reza, I pass the controls over to you, and you can make your you can start your presentation. Thank you.
Thank you. Oh, does that work?
I see it. Yes, I see you. I see full screen.
Full screen. Okay, perfect. So thank you very much. My name is Ali Reza Parandian. I'm heading the global business strategy for wearable applications at Materialize. And as David has been saying, eyewear is one of the major applications that we are working on in the domain of wearables. And David, yes, I also remember that additive manufacturing of eyewear started out with a few players a few years ago, with a few brands that were courageous. But I am very happy to look back now and see that where we started with a few, many respected and emerging brands are recognizing the value of this technology. And really the greatest witness of that, I think, is that we observe that product lines are emerging. But more important than emerging is that they're evolving and developing over time, so they're here to stay. So more and more the technology is being used not because it's hyped, but it's because it offers a core asset to the eyewear industry, in my view. So literally, I think that we've seen the number of companies active in the field growing. One to many, a number of frames from very few to thousands to now hundreds of thousands being produced by additive manufacturing, and you named the key technologies that are being used there. I think I have an important message to say and it's that while many always talk about the advantages of 3D printing being adopted by new companies or startup companies that want to have a de-risking advantage to step into the new field soon. I think that a significant growth, which we will see, like you showed, will be by the adoption of the technology by more significant established players in the field. Now, see if this moves forward. Yeah. So I think the core message or the claim that I have today is that unlocking the transformative potential of additive manufacturing for eyewear needs to keep in mind four different topics in order to guide the journey as it takes shape towards what we call transformation. And I use the word transformation quite consciously here instead of disruption. So let me take you through an example that we have brought to the market, as you've mentioned, that considers all four of those topics. So let's start by product innovation. We brought out Uniku with our key partner Hoya, one of the top 3 companies in the lens industry. And by doing that, we created a new category in the vision care sector by creating really the first and now still the only first fully personalized eyewear. And I think you forgot to mention, David, here it's combination of the performance, or the visual performance, the comfort of the user, plus the style that can be personalized. It's product innovation because we considered really the function of correcting for vision as a main topic for development for this digital platform. We sort of prioritize positioning of the lenses first instead of correcting for the position of the lenses given the frame that was selected by user. And by doing that, we actually changed the whole way that the development of algorithms towards design of lenses were approached. So this is what we call vision centric, and especially in multifocal lenses where the aging population has more and more demands for this kind of lenses, is becoming much better than the best lenses that is out there in the market. Uniku is a digital platform, but it is a digital platform which is designed for an in-store experience, and it really considers the professional in the store and enables them to boost the services that they provide to their customers so that they enhance the loyalty of their customers into their store. In order to do that, we needed to develop a full end-to-end system. As you see on the image, we developed the hardware that was accurate enough to be able to capture the images. We developed the whole software flow, not to design one product, but to automate the design of many products. Nobody is touching the product there, and to create a open platform for many designers to be able to join, linking that to the backbone of the manufacturing that we have. Of course, as I mentioned, professional enablement means that the eye care professional has already some roles. They are personal guide to their customers that come to buy frames. They choose the right frames from the wall. They are experts in measuring what kind of visual needs you have, what kind of corrections you need. But we try with Uniku to really extend this role to becoming a tailor, to co-creating together with the customer what they like, and to create something that fits the style and the needs of the individual. By that, we try to really bring co-creation onto the shop floor, engaging the customer in the product development process itself as well, not neglecting the complete expertise of the eye care professional, but allowing the customer to have a say in the product itself. Obviously, operationally, this means that we are designing a frame on the face of each individual, and we're ordering only one frame for that individual. So it's on demand, made to measure, the end of average, and limited, almost no waste in that production line as compared to what you have today. I think finally, in terms of business model, these digital platforms could do to eyewear what iTunes did to music. And that's because it allows the different brands that are established or are new and coming to interact with their customers, who will be the eye care professionals and their customers, in totally new ways. But this all was not possible if there was not a collaboration with courageous people like Bike, who is in the panel today, that wanted to push the boundaries, that wanted to try out new things, and that really drove the developments and innovation in this field together with us. As I say, it's we offer the piano, and it's the composer, as of the designer, playing the notes to create a great harmony. And you see that in the pictures that are on my screen. See the first woven structures that were created together with BK. Other brands like Vava, where we collaborated to bring unique elements by, creating added functionalities by integrating 3D printed hinges and lens exchange mechanisms into the eyewear, but in a way that it was still stylish to be sold in boutiques as well. And we made performance more personal together with BK and Seiko. This was many years ago, and these frames were very important. I think the Silmodor Award at that time, it was very important because it attracted really the attention of this industry to this product. Really at that time, I think what was really important with a brand like Seiko to come to the market was that this material and this finishing was good enough and that it could be performant. We actually put this product to test. We sent it to the most extreme places on Mother Earth, North Pole and South Pole, and made sure that it came back exactly the way it was made before. But I think what was important in this journey as we came along in the past years is that we really didn't only focus on innovation and innovative technologies that we were trying to offer to this industry, but that to look into the tradition of this technology and see how we can really combine the two and use it to create beautiful parts. Wearable sculptures was a collection that you also showed in your presentation, is a collaboration between Materialize and Safilo, one of the key players in the frame industry. And I like to quote Nicola Belli, who said, "Beauty lies in creating an emotional response." And I think that's what you see on the screen here. That comes from how materials are used and not what they are. So people feel beauty. It's that moment of wow, that shapes, looks is something special. So polyamide 12, as you said, nylon, doesn't sound sexy, but playing with it as a lightweight material, using the material and the post-processing methods that we have put in place, you are able to create products that are beautiful. And beauty never lies, because you can use the same material with different kinds of finishes for every single designer that comes into our atelier, you could call it, so that it really represents the DNA of that brand. And every single frame that leaves the factory will have to represent every single brand's identity. So in that sense, I think there is a lot of variety already in what is offered to the market. And to end, there is, of course, new materials. Hood in the couture collection has used titanium for many years, but since recently we are offering titanium through the McLaren collection from Lamy in very large volumes to the market. So fasten your seatbelt. This field is not going to stop with one material. There's going to be many materials, many different finishes possible in the future. I think an important statement about making frames is that we're moving with 3D printing in this field from a more general purpose technology. You know, the machines are made to make many different parts for many different purposes, to a more application specific field, which requires certified manufacturing factories. And that is exactly what we set up. Materialize has a certified additive manufacturing setting for medical applications, FDA approved. We have this for aeronautic applications, but also for eyewear, we have a certified manufacturing factory, which complies with all the norms of the industry. 4 main pillars for growth, I think you mentioned as well. You need to be scalable, obviously, in terms of quantities, but this scalability needs to take quality with it itself. So this needs to be consistent quality as you scale up. And this is the only way to do that is what I mentioned, to move more into an application specific setting, having factories that are more focused on quality control and getting out of the prototyping mentality for creation of eyewear. You need to offer variety because this field, the players in this field want to be different and need differences, even if it's in details, and you need to offer flexibility for growth. A lot of people think about the cost dilemma. This is mainly what people know about 3D printing. Obviously, in comparison with conventional technologies, that 3D printing, in terms of cost, doesn't matter whether it's 1 or 1,000, the cost will remain the same. Well, I think I have news for you. I think that there is efficiency coming up as volume grows and through these application-specific working settings. There is automation in post-processing coming up, which allows us to reduce costs. So by volume going up, as the demand increases in this market, the costs will drop, if not significantly, but they will eventually drop to lower prices. And I think we do have to consider that there are new materials being developed and that the processes are becoming much faster as we go along. You mentioned, for example, the HP technologies coming to this field as well. And I just want to my final slide point out that it's important to think about this field as a triangle. It's of course the technologies, it's the materials, and it's the post-processing technologies that come together. But also within the field of materials, we are now collaborating with I think the largest chemical company in the world since this summer, and one of the major pillars of our collaboration will be in the beginning focused on the application of eyewear to create new materials to offer to the players in this field what they request from us. Thanks.
Thank you very much for that. There's so much. You covered a lot, and I actually have I have a couple of questions for you. I will keep them for the end. Next, I would like to give the panel over to Biki. Let me, so we can. So Biki, you're all set. If you should be able to now show your presentation, and we can look at a little bit of you know, how you started envisioning these possibilities.
Yes, the 3D printing journey, let's say. Is everything clear? Can you see my screen?
Not yet.
Not yet?
No. We see the webcam, but I think you have to select the button on the left-hand side of the control panel. Wait, let me just make sure. Oh wait, sorry, my fault. I didn't make you a presenter yet. That's why.
Okay.
Sorry.
Yeah.
Okay, so now you should have a perfect. There we go.
This is okay. Okay. So yes, presenting myself. So my name is Bieke Hoed. I'm representing the design studio with the same name, since we are a family business with quite some heritage in the optical markets, let's say. It started about 130 years ago with mainly optical retail activities, which today we still have. We still have 2 shops, one in Brussels and one in Bruges. And some change came after the last 30 years, where we started to design frames, actually with my father, who founded the company Theo. 30 years ago, together with his commercial partner, Mr. Somers, and where my father was actually the creative director of the styles for tables. We still today design about 60 to 70 frames a year for TO, besides all the other designs that we currently make. 20 years ago, I came into the company. I was, and my main goal was to look to innovative solutions in different industries, and to see whether they can find an application in eyewear. And that is actually how we fell into the 3D printing. I, being a member of a database of all kinds of new materials and technologies, I ran into the 3D printing on dental applications. So I thought, yeah, this is metal. It can be printed. It is anti-allergical. So why not make frames out of it? So that is how it started with the 3D printed titanium frames, which are now more or less 6 years on the market. And simultaneously, I also noticed other materials like the polyamide, to experiment with the technology and to see how we can push it to its limits to create frames from it. So that was our goal, and that's where we are today, with offering our freelance design services to other companies, and also wholesale activity of 2 private label brands, the Hood Couture collection and the Kabel collection. Voilà. We are designers, so we feel responsibility, because we feel responsible for everything that comes on the market actually starts with the design. We are in the beginning of the chain of production of everything. So we have a social responsibility, we think. So everything we do or we bring on the market, it should give an added value, or there should be a reason why doing it. So therefore, for us, the 3D printing technology and it's the way how we can actually also reduce the waste with this technology is really important to us to invest in this and to promote it as well. Secondly, we need to design our frames also to be able to connect services to it, because if we have to design our frames in a way that they can answer very fast to all the applications that are in the market, to offer customization, and to also be very fast in the rescaling and so on. So this is also something that we as designers have to look at very closely, how this everything in around us is moving. The third reason, there are many responsibilities, but only 3 here, is of course an aesthetical responsibility. We see that we have to, in a way, with our designs, reflect a time spirit and translate it into a product. Since everything these days is going to digitalization, so everything becomes digital. And also we see for the optical market, it's only in its footsteps of digitalization, but of course many things will follow, since it's coming in our world on every field, let's say. For the aesthetical responsibility, so I'm giving a little bit my insight as a designer, of course, and how we look at products and why we worked with the 3D printing and we see so much potential in it. Being also a woman, I have to cook a lot. So I think, like, how can I describe a good design in a way that it's understandable for other people? So it could be said that it is like a recipe where you have taste, perfume, texture, all the ingredients of a good dish are coming together and have to create a unique experience. And that's the same with the design. Only the ingredients are a little bit different. The ingredients for a good design are the functionalities, the material, and the shape. Only in this way, with these three components, we can create something that can give an added value, or that can be a little bit upfront to set a new trend. And looking at the 3D printing technology in specific, we see that for the shape, of course, there is an endless freedom of design. It's like growing like a tree. The 3D printing, you can build particles together in any kind of way, direction, and so on. So the freedom from design is quite big. The materials, polyamide is a new material in the eyewear industry, with bringing, of course, new opportunities, but also some challenges, because it is getting better. But of course, launching a new material on the eyewear market, it needs some time for acceptance. But we are very far in that, and it's also our goal as a designer to cover the limitations, because out of the limitations grows the creativity. Functionalities, of course, function. There are new functional parts. We can create new ways of mounting lenses, of creating hinges, and so on. So, for example, on the functionalities, on the right up, you see the titanium frame, 3D printed. And the structure of the frame is with a honeycomb, allows the flexibility in the titanium, which is not possible to think about when it would be a solid element. And it allows to mount the lenses without screws or any kind of fixing tools. Another example of the functionalities is the bendable part at the end of the temples that is realized by perforations in the polyamide, and which allows to adjust very well the frame to your face. So these are developments that we did that came out through the working with new technologies. Material experiences. There's possibilities of surface texturing, flexibility, but of course this is just in the start, since new materials are getting on the market very fast. New machines are getting fast. So for us as designers, we are like filters. You have to catch everything and see what are our tools to work with. The shapes, of course. The endless freedom of design, it allows to do the very complex structures that give very small detail, or maybe larger detail could be, and it's very, let's say, today a reflection of what we can do with eyewear. So having the ingredients together of the functionality, freedom, and the material, there's also a fourth ingredient, which is the combinations with traditional production technologies. So, and that is where our experience in the eyewear industry is very important, because as I said, we have, as a designer, we are like a filter, and we are living in a world where we capture a lot of things. And it's our responsibility to filter everything and to come out with something that is unique, that is a social responsible design, aesthetical design, and a design that is open for services like customization, like all these other things that are coming. Today, we different than David his prognosis. We already are working for almost 50% working on 3D printed frames. So in our design office, 50% is still made by traditional production, but the other 50% of all the designs that we make are are done by 3D printing, whether if it's metal or is it plastics or if it's a combination of both. So we are really convinced in the potential of the technology because, yeah, I think I explained before. Some on the right hand, you have some of the brands that we are designing for, which is a very nice selection, and where we try to translate their language into frames that are really answering everything that I said before. So this is what I could share. I hope this was interesting. So please do not hesitate to ask any questions later on.
Thank you very much. Thank you very much, Vicky, for that. That was fantastic. And then now I will pass the controls over to Guido Groet from LuxExcel to kind of close the circle. We talked about frame production, frame design, and LuxExcel is a very, very unique company that makes lenses. And I actually visited the company because I could not figure out how do you make lenses with 3D printing, and it's I learned a lot. I learned a lot about this business. So I will now pass the controls over to Guido so he can tell us more about this, and then we can take questions and discuss how this all comes together. Okay, so Guido, you have the control.
Okay, hang on. Can you see my screen, David?
Yes.
Okay, well, thank you all, everybody. So I'm Guido Groet with LuxExcel, and we 3D print lenses. We started off a number of years ago, and we started off by doing prototyping, like many people in 3D printing. And then we figured out that within prototyping, we would never really make it all the way, because after we put in all the effort, people would take the technology and the design they made and move it into some other form of manufacturing. So we actually decided to focus completely on the application, on one application, and we selected eyewear. We selected eyewear because it's a big market. There's a need, in particular in the lens space, for individualization, so a custom product for each user. So large volumes customized towards each user. And so we felt it was a good fit to our technology. So today where we stand, we're 100% focused on eyewear lenses, so ophthalmic lenses, prescription lenses. And where we stand today is we believe we're the only company in the world able to 3D print lenses. And we're doing that every day. And I'll show you in a minute, I show you a little video from a couple of our customers where they tell us how they feel about that. Like mentioned before, ophthalmic lenses, so prescription lenses, are a medical device, which makes it a little bit more complex. So it needs certification. We actually have all the FDA approvals. We have all the ISO certifications required to make prescription lenses, pretty much all over the world. And what we see is that enables us to, well, let me rephrase that. A lot of people believe you cannot really make lenses. It's too complex to, it's hard to do. Well, we've shown that we pass all the certification and we are actually in production at the moment. So don't take my word for it. Actually, I have a little movie that I'm going to show you. We had some problems earlier, so I hope this works. But David assured me that if you cannot see the movie correctly, we'll share it afterwards. So let's hope the World Wide Web works with us. So I'm going to run this video here, and it's going to show you a couple of our customers giving their view on ophthalmic lenses. And at the end of the video, you'll see a little bit inside our machine how the process actually works. And at the end, I'll explain a little bit more what you've just seen. So let me start the video.
So 3D printing is the next step in manufacturing. 3D printing and additive manufacturing is the future in the US of all forms of manufacturing. LuxExcel was the first partner and the only partner in the world right now that can 3D print lenses that have ophthalmic quality.
We print lenses every day. The lab's in production 2 full shifts, 16 hours a day. We produce the lenses on both shifts. So and we're able to produce lenses that otherwise would not be able to be produced in-house.
So what you've just seen is the view from a number of our customers on what they're doing with our technology. So they're printing lenses, and I'll get in a moment to what lenses and why they're doing that. At the end of the movie, you saw inside our printer a time-lapse movie on how we print these lenses. And you can see that they become fully transparent right straight out of the printer without post-processing. So there's no polishing involved. So we basically print these lenses, in a way that they're usable right away by the user, even though they might need still coatings or other additions to make them better for the user. But as a lens, they're usable straight out of the printer. So we have developed this technology, and since we started doing this, nobody believed that you could actually 3D print lenses, which was good for us because currently we find ourselves alone in this space. But at the same time, it also forced us to develop our own printers, our own materials, our software, our print recipes. And so that's why we currently are the only ones in this space, because we put on all the effort. And we currently provide this whole solution as a platform turnkey to people who want to make ophthalmic lenses. And we actually we offer this as a full package. So we try to make it as smooth as possible for them. So we try to remove all the hurdles why people would consider not 3D printing something. We remove all the hurdles. We provide a turnkey solution. We take all the technical challenges on ourselves, and we leave the customer the commercial challenges selling the lenses. And we find that really helps in convincing people that this works. Of course, there's other aspects that go into it. You need, of course, have the certifications, which we do. You need to have the quality, which we do currently. And you need to be able to offer really something unique to the customer. And so that brings us to the next question. So why would people 3D print a lens? Well, first of all, there's an efficiency aspect. So currently the eyewear industry, the ophthalmic lens industry, it's a very complex industry. It requires enormous investments. I don't think there has been any new entrant in this market in the past 20, 30 years, because it requires such big investments to set up this whole supply chain. So these lenses are made as semi-finished lenses somewhere in Asia in monstrously big factories. A lot of energy goes into it. And these semi-finished lenses get transported all over the world until they're very close to the customer. And when you order your prescription lenses, they finally get made into your prescription at the end stage. So we can cut through the whole chain by just putting the printer at these ophthalmic labs and make the lenses when you need them, so cutting away the whole chain. So there's a huge efficiency step that can be made. Like mentioned earlier by some of the other presenters, there's a lot of waste that goes into that whole process. At the end, this plastic that's been manufactured all over the world, been shipped all over the world, most of it gets thrown away in polishing and in cutting the lens to the final shape. And of course, that's something you will not have when you 3D print the lens. Those are all efficiency aspects and eco aspects. The bigger thing from a customer perspective is, of course, that with 3D printing, the customer can actually get the lens that they want. They really can get the end product that fits exactly their needs. And that's where we think 3D printing can bring a big difference in creating these lenses. Because the existing industry has done a great job at developing a process that works, that does it efficiently and makes great quality lenses. But it does that at the expense of really customization. So it does it at the expense of flexibility. And with 3D printing of lenses, you can actually get the product that people actually need for whatever they're doing. And one of the additional things, which is my last point on this slide, it enables also to really bring smart eyewear to the world. And I'll get to that in a moment, what that means exactly. So first of all, let me explain what is 3D printing, what can LuxExcel offer the eyewear industry. Well, we bring the 3D print technology to the market, to the eyewear market, which doesn't exist today. And our strategy is to really start in certain little market niches where we make specialty lenses that are difficult to make today, but in existing market segments. So it's a little bit a Me Too product. It's the same thing that exists already, but except that we'll make it easier to make. It's easier to use our technology to get these lenses. So we start in these niches, but where we really want to go, we want to make the lenses that are impossible today. We want to make the lenses that really make a difference, that do not exist, because the current manufacturing technology does not allow you to make those lenses. So I put this in a nice chart here. So if you map the lens market, the prescription lens market, and you go on the horizontal axis, you see the volume, and the vertical axis, you see the value. You see the traditional eyewear lens industry is very much focused on making these products. And these are pretty standard products. And basically, I mean, of course, everybody claims that their product is different, but all these products basically do the same thing. Some of them are extremely low value, like the readers, reading glasses that you can buy in any drugstore. And a little bit more expensive are the progressive lenses. But at the end of the day, everybody sort of does the same thing. So there's a lot of competition. It's really, we call it laughingly, a shark tank, where everybody eats each other. So we said, you know what? Let everybody else play there. We're gonna enter some specialty markets. So we're gonna start off in all these niches, and we picked a couple of niches where we think we can make a difference. And we said, you know what, we'll make these lenses. They're difficult to make. People are not happy with it. The traditional industry doesn't like it because it disrupts normal production. We'll start off in the specialty lenses. What we really want to do is we want to make the lenses that do not exist today, where you, for example, integrate electronics inside a lens, or you integrate certain filters, active or passive filters inside a lens, or you can actually make lenses that switch optical power electrically, or you can make lenses that have multiple refractive indexes within one lens. And of course, also products where you can maybe integrate a frame with a lens and come to completely new designs. So that's basically our path. So we said, you know what, we're going to not enter the mainstream market, let other people fight over that. What we do is we start in the difficult lenses, and we'll go to the non-existing lenses in the future. So, like I mentioned before, these smart glasses, that's a big market. A lot of the people, the Silicon Valley people, as we call them, are focused on that, trying to bring smart to eyewear. We've seen it with our phones. In the past, we had the dumb phones. If you look at the phone your grandma uses, it's very different from the smartphone you have on your desk today. So it's because a lot of smart got added to the phones. And that's happened in a lot of industries. Even your fridge is starting to get smart. But your glasses today are not really smart. So with our technology, you can actually integrate smart into a lens. And by bringing smart, you can really come to new designs, new functionalities, which I believe are the glasses of the future. And today, some people are making tryouts in that space. But if you look at some of these glasses, these smart glasses being developed today, the ones at the bottom there, they don't look really like what we would wear, going out on the street today. The reason these things are so ugly, if you like, are too big, and they don't look like the glasses you see on the top, is that the technology companies do not really get involved into these glasses, into these medical devices. They expect people to wear their glasses underneath. And that's why they're so big, and that's why they're so ugly. And the reason they do that is, medical devices is a different animal. It's really a different product. You cannot stock them. You need to customize these lenses. So there's many issues with that the technology companies do not want to address. Eyewear companies, on the other hand, are very comfortable making their lenses every day, and they kind of go, well, this smart thing, do we really need it? It disrupts our chain. And all of these eyewear companies, you need to remember, have enormous investments in the existing supply chain. And we feel with 3D printing, we can really step in the middle and kind of bridge this gap between these two technologies. The reason our technology is so fit to, for example, make smart glasses, but also to make all these other products I mentioned earlier, is we can actually print half a lens, put the electronics in the middle, and print the rest of the lens. So we can actually make sure that the new glasses with the functionality, with the technology inside, really fits exactly in a normal frame. So we can actually bridge the gap between these two technologies, which puts us in a pretty unique position. So in summary, and this is my last slide, well, we have this eyewear industry. It's a big industry. It has met a lot of vested interests, and it grows by a few % every year. but no major changes have happened. And we believe 3D printing can really bring that change by bringing customization, but also by trying to allow new entrants to enter the market. We see many trends all over the world with smart stepping up, and we feel that we can help bring smart, but also bring customization for the end user to the market. We feel 3D printing can play a significant role. We feel very lucky that we are pretty much alone in the lens printing space. And the good thing is, well, a lot of people believe that you can have really 3D print lenses, and well, we have proven that it is possible. We'll keep proving it, for the rest of the year. And in the meantime, we're building up partnerships with people who really want to bring smart to the world. And that's basically what I wanted to say.
Thank you very much. Thank you very much for these presentations. We went a bit long, but I think it was really worth it. I think there was so many interesting points being made here. We do have we can take questions now. We have a few questions. I have one for Alireza that I wanted to ask before. So it didn't come up in my presentation, but one trend that I expect is that in the beginning, a lot of companies will reach out to companies to serve 3D printing services or 3D printing outsourced factories like Materialize for the production needs. But eventually, they are all gonna look to bring their production in-house. Do you see this as a risk? Do you see this as a challenge, especially those large companies that you mentioned as potential, adopters? In my projections, 3D printing services will continue to grow, but even if companies would decide to bring some production in-house, how do you see this as a risk and or as an opportunity really to just really exploit this segment in the short to medium term?
Thank you for the question. As Materialize, it's absolutely not a risk. Obviously, the forgotten part always to talk about 3D printing is that it's mainly about software, and it's software that really drives in the application-oriented additive manufacturing that does the job, tells the machine what to do. And as you know, the Materialize is a leading company in the world of software. So for us, it's an extreme opportunity if companies start to adopt 3D printing technology in-house, and they will become a customer of Materialize again. So we print, you print, doesn't matter.
That's fantastic, and that also introduces the first question we have from the audience, which says, are there CAD packages, and they mentioned Rhino, etc., that support generative design of lenses, frames, components, or is industry progress dependent on custom software solution or lots of manual work, labor, skilled workforce for each iteration of design? I guess this is for you, Alireza, but also for Biki.
Yeah.
And also for Guido, if you want to add something.
Yeah, I think this is definitely one for Biki. She can reflect on how she uses them and collaborates with us.
Yeah, so there is not a specific software to design eyewear, but we work now with SolidWorks, but also combinations of Rhino and for more freeform solutions. So it depends a bit on the designer where you like to work with. There are several packages and software, but they are more general focused. They are not really focused on eyewear. And to be honest, we work with SolidWorks, and we use only a small package of the potential of the software, because a lot of tools that are offered in all these CAD systems are focused on all the industries. So yeah. So yeah.
Thank you. That's great. But did you want to add something, Guido? Because I know you also invested a lot on your time.
I wanted to say for lenses, it's a different animal, because there are, of course, lens design packages that make lenses, but none of them, they're not focused on eyewear, which has specific requirements. It talks about diopters instead of curvatures. But also on the eyewear space, there's a lot of lens design systems, but none of them have flexibility to really make individual lens designs. So there's not really a package. That's why we have developed our own lens design system that we provide to our customers.
Thank you. And the next question is on materials, and it's an interesting one. Is how are new 3D printable materials for eyewear tested to make sure they can be used on consumers? I guess this would be also for Alireza. How would, I guess, in your specific case, but maybe we can also kind of expand.
Yeah, it allows me to expand a little bit on your previous question as well. It's because now 3D printing, as I said, is a sort of a general purpose technology. And so you will have to have a lot of expertise in-house, software, engineering, and technology, how to fine-tune all of those to make sure that you can run several materials and get in the end the sort of application requirements that you have. In eyewear, we use at this moment a lot of powder bed technologies, as you mentioned, with polyamide 12 as definitely the most interesting material that fits into the field. This has been severely tested in conditions that are prescribed in several certifications, industry certifications. But what is important to understand is that there are several post-processing steps coming afterwards, and these post-processing steps keep developing, and we want to offer the big variety as well. So we're not just doing tests on the basic material level, we're doing also tests on all the post-processing steps and materials and things that are being used there, all the way to the top coating that is delivered to the end customers. It is an answer to your first question as well, is because not every player can just take this technology in-house and start doing it next day. You need to have a lot of expertise under one roof to be able to manage this in a scalable quality fashion. So new materials, how do they get developed? Together with the industry, really, together with people like Bieke and her peers in the industry, we dig into their needs, what the designer would like to reflect as their DNA, how they would like to bring a more differentiated offering in to the field. And this is by comparison to what they have already on the palette and what they wish for in the future, what is not available today. So it's a lot of co-creation that has to take place so that we create a material that really meets the demands of the designers who create really new products for individuals. They really understand the tastes of the market as well.
Thank you. Did you want to add anything, or we can move on to the next question, which is also very interesting and very much connected to the discussion, and is if we expect the future of 3D printed eyewear to be more driven by services or by products. Of course, it's kind of generic. I'm not sure I can. Maybe I should answer that, but I'm not sure I can. I guess you would have to really identify what we mean by services and by products, because with 3D printing, I think the line can be blurred. But I'm guessing by the services, I guess we could consider everything that goes into the customization and the design, and products would be the end use product. And I guess in my projections, it would be first by services and eventually by products. But that would be kind of, first you need to build the ability to provide the services, the customization services, and then you will be able to produce, even mass produce customized products.
Yeah,
that would be
David.
I don't know if anybody wanted to add something.
Yeah, David, I was just, I think for the future, I think the service can come when everybody will have a digital passport of himself. Like you will have the hardware will be found anywhere where you can have your digital passport, and then it will be the customer who will look for a product or who can order a product that is answering his needs for his personal digital parameters of his head. So yeah, there will be eyewear on the shelf, and that will be pointed out as this one is one that could fit you good, following your digital parameters, and so it will come together. I think it's not going to be first one or first another.
I think it makes perfect sense.
Can I add something to that? So what we're doing actually, we find that we need to help develop some of these products initially to make something really unique to show people what is possible. That's what we're doing currently. We're working with a number of companies, creating unique products, unique features, and then eventually it will turn into a service where it gets the final customization will happen, wherever at the shop or at some closer to the end user. But we really have to make the first steps ourselves to show why 3D printed products make sense.
Absolutely. And I have another question for you, Guido, is if you have a functional prototype of your screen embed lenses. I'm not sure you have screen embed lenses. Maybe they were referring to some other electronically activated lenses, but maybe I misunderstood. Do you have a prototype of screen embed lenses?
Yeah, sure. We've made a number of lenses that where we actually integrate certain functionalities in lenses. For example, we have made prototypes of electrochromics where you tap the frame and they change color. So that's where we integrate an LCD screen inside the lens. We also have active polarization filters. You tap the lens and all the glare goes away. And then, for example, when you want to read your phone, polarization filters don't work nicely because you cannot read LCD screens. But we can actually switch off the polarizer. And also, we've made a couple of prototypes together with a company in California where we actually have a little screen inside the lens with a big gloss lens in the back. So you can actually, it's very close to your eye, but you can still read the screen. And then you can show information inside the screen. So for us, it's fairly, well, I shouldn't say easy because my people will get mad at me, but we can actually print a lens, put stuff in there, and print the rest of the lens. And of course, it's very complex. And of course, to make it really good, it's difficult because at the end, you also need to integrate whatever electronics you put in there. You need to integrate that with the frame. So there's a lot of work that goes into that. But we certainly have prototypes where you can actually have a lens of the future. And I think you'll see more of that coming. So there's so many applications for that, like little lights for somebody who's on a bicycle. You can know, like the bicycle, you know that there's a truck behind them because there's a little light that comes on. So all of those things are fairly straightforward with our technology.
By the way, I now travel around with one of those mono wheels from Segway, so I really could use that technology. We actually have another question for you on your materials for the lenses, and what are the criteria for the materials, and the question is, what do the certifications involve? What kind of certifications are involved?
Well, there's certain legal certifications, there is industry expectations, and there's consumer expectations. So let's start with legal certifications. For certain markets, you have specific legal certifications. For example, for the US market, you need to prove a certain breakage resistance. And so that's the FDA certification. So that's a very important one, otherwise it's basically illegal to sell lenses if you do not pass that. There are industry certifications which are mostly described in ANSI and ISO standards. There's like 5 of them that you need to match, and it's mostly related to accuracy, smoothness, transparency, transmission across the optical spectrum. So there's a bunch of those. And then there's consumer expectations. So consumers have a certain wish. So they do not want lenses that are too thick. So you need to make your lenses very thin. It's a big driver in the industry. They shouldn't look funny. You cannot have, even though there might be distortions here that don't really matter, people will not accept that. So there's a lot of quality requirements and aesthetic quality requirements from the customer side, from the consumer side. So there's many different levels of requirements, and that is what I said earlier. Is in the past we did prototyping for many different markets. It's very hard then to understand what all those requirements are because there's no book that describes those. And that's why we selected one application, Eyewear, because now we can learn exactly what all those requirements are, those unwritten requirements are. And that's what we spent the past few years learning. And I'm sure Bieke knows a lot of these in the eyewear industry, but there's a lot of places, there's a lot of unwritten rules in every industry, and that's why we learned all those rules for eyewear.
Okay, thank you very much. I think we went pretty long, but I just really kind of wanted to close up. If anybody wants to have any closing remarks, I have a very quick question for Ali Reza. Would Materialize ever consider? I mean, is there a future where you would be using a technology, such as LuxExcels to make the full eyewear, glasses, the full product, or is this technology is Materialize? Because you did mention this drive going towards more and more specific applications, but is this too specific for a service like Materialize?
Well, at this moment, no. The question on the short term, very near short term, no. But as you know, Materialize it has as one of its business models to be a service bureau. And when a technology becomes very interesting to our customers, we may adopt that. They deliver the same things that we buy from other manufacturers as well. So I don't see why not, but it's not in our near-term strategy to offer 3D printed lenses, which is the reason why we are collaborating with companies like Hoya to offer normal produced
Hoya
lenses.
would be the company that could consider, that would be getting something. If they were going to be printed lenses, they would be the ones to be doing the lenses, of course. Yes.
Of course. And the reasons were provided by Guido. So yeah.
Okay. Fantastic. I don't know if you wanted to, if anybody has any closing remarks, or like I said, the video will be made available. The presentations, the parts that we can share, the ones that we can share will be made available as a follow-up to these all participants. We actually had a lot, so thank you very much for participating. I think this is a very, very interesting topic. Like I said, it's probably the first product that's going to be significantly, the first consumer product that's going to be significantly produced with 3D printing technologies. So I don't know if you had any closing remarks, or we can close.
Thank you.
We're all set.
See you
Okay.
next time.
Okay, thank you very much. Until next time. The next one, I think our thank you everybody. Our next AM focus is going to be on I think it could be large format 3D printing, so an entirely different topic, but we'll talk about that on 3D Printing Media Network. Thank you very much, everyone. Thank you very much.
Okay. Thank you. Bye bye.
Bye bye.